Use the factor theorem to completely factor if the second polynomial is a factor of the first polynomial. Since we're given this information that the second polynomial is already a factor of the first polynomial, all we need to do is run through a synthetic division to double check that it is in fact a factor. Since we're using a synthetic division, we need to use the opposite of this -1, and that will go in our box. Then, to complete the synthetic division, we will use all of the coefficients in our first polynomial. So 1x to the fourth, 2x cubed, -7x squared, -8x, plus 12. Running through the synthetic division, the first coefficient always comes straight down, and then we will multiply the 1 times the 1 and get a 1, and we will put that in the next column. Then we add these stacked numbers here. 2 plus 1 is 3. And then we repeat this process. 1 times 3 into the next column. That's 3. Add the stacked numbers. Becomes -4. If you continue repeating this process, you will see that we end up with a 0 remainder. Now we need to interpret our answer. Since we started with an x to the fourth power, the first term will be x cubed, and then we just decrease our powers every time we move to the right one coefficient. So this will be 1x cubed plus 3x squared minus 4x minus 12. Now that we have this answer, all we need to do is use factoring to completely factor our original polynomial. And to factor this, x cubed plus 3x squared minus 4x minus 12, we need to use factor by grouping. When you group the first two terms together, you're able to common factor out an x squared. So that leaves you with x squared times what's left over when we do this division, x cubed over x squared, it is x. And when you perform this division, 3x squared divided by x squared, you're left with a plus 3. And now we need to group these other two terms and common factor again. When you do that, you end up with a -4 being common factored out with an x plus 3 left over inside the parentheses. Now we can common factor this x plus 3 and when we common factor that away, we're left with an x squared minus 4. And then at the very end, we are going to put our original factor, x minus 1. And we are almost done. The directions say to completely factor. Well, since we have an x plus 3 as this factor, that can no longer be factored. We have an x minus 1 over here, that can no longer be factored. But right here in the middle, this x squared minus 4, you can use difference of squares factoring to factor this polynomial into x plus 2 times x minus 2. So we have x plus 3, and again this middle factor factors again into x plus 2, x minus 2, and then at the very end we still have our x minus 1. This will be your final completely factored answer.